All right, welcome to the video notes on matter. Let's take a look and see what matter is and how it's classified. All right, so we're going to start with a little snippet from what we saw last unit when we took the components of the universe notes. Here we said, remember, the universe is made of two basic things, matter and energy. And last unit, we focused on the energy part. This unit, we are going to be focusing on the matter part. All right, so hopefully you know by now from middle school or elementary school that matter, all matter, is made up of atoms, right? So that's the smallest building block of matter is an atom. And we're going to go into detail in a few lessons about this structure of the atom, and then figure out, how the structure relates to, what kind of compounds they make and their characteristics like that. But we're going to keep it simple in these notes, and we're going to say that atoms, okay, can make or make up elements and compounds. And so the difference is that when atoms of all the same kind, or we call pure, right, or all same kind, okay, if atoms of all the same kind come together, that's what we call an element. If different types of atoms come together, so let's see, different types come together, okay, they're going to be called compounds. All right, so that's the difference between elements and compounds. Elements have one type of atom. For example, oxygen, the air we breathe, the component of oxygen gas is made up of pure oxygen atoms. Okay, versus a compound, like when we breathe out carbon dioxide, right? So CO2. All right, we can see that there's two different types of atoms, so we call that a compound. Carbon and oxygen making carbon dioxide. All right, now what we can realize is that the air that we breathe, right? Hopefully you know this, but the air that we breathe is composed of nitrogen. Okay, that would be an element. Okay, oxygen, again, two atoms of the same kind is an element, and carbon dioxide, right? And so that one we said was the compound. But all of them exist together in the atmosphere around us. And so if they are all together and they're not, making chemical reactions or new substances, we call that a mixture. Okay, so a mixture can be a mixture of different elements that are not reacting with each other. Or it could be different compounds that aren't reacting with each other, but the key is that they're just hanging out. Okay, elements and compounds that are just hanging out together are called mixtures. They're not interacting. They're not making new things. They're just hanging out. Okay, so that's kind of the basic idea and premise of what matter is. All right, so you're going to want to copy this slide down. And in the last slide, we basically took a look at this concept, matter is made of atoms, right? Matter, two key characteristics of matter is that matter has to have mass, okay? And all matter takes up some kind of space. So matter, and it could be, the tiniest, tiniest, tiniest mass and the tiniest, tiniest space, but in order to be considered matter, it has to have mass and take up space. All right, so when we classify matter, we classify it into, the different states of matter. Okay, so you've seen this before. Since elementary school, you've seen this before, right? Solid, liquid, gas. Those are the states of matter. So every substance can be either exist as one of these states of matter naturally, okay, or they could be forced into that state of matter by adding energy or temperature or pressure, changing the temperature and pressure in order to make them go from a solid, liquid, or a gas. Okay, so what we're going to do is just kind of underneath the solid, liquid, and the gas, we're going to draw what little molecules or atoms of a particular state of matter would look like. And we're going to represent their motion with arrows. Okay, so a small arrow is going to mean slow. All right, and a big arrow is going to mean fast. All right, so we're going to start here with the solids. Solid compounds, right, are compact together. Okay, so they're real close together. Okay, so they're compacted. Okay, and for the most part, they're not moving. Okay, they are just kind of standing still. So we put a little tiny little arrow, okay, for the motion. So solid compounds are basically kind of standing real still right next to each other and just kind of vibrating back and forth, okay. That's molecules that are in a solid state. Now, in a liquid state, let's take a look at the liquid state. In a liquid state, it's a little different. We get a little bit more energy. In fact, remember with our heating curve, right, that we saw that as soon as you add more energy to a solid, it will start to melt and turn into a liquid. So when we're talking about liquids, they're going to be a little further apart. Let me increase my dot width. There you go. Okay, so they're going to be a little further apart. Right, and they're going to be moving a little faster. Okay, so remember, to get from a solid to a liquid, that is a phase change called melting. Right, and to go from a liquid to back to a solid, the opposite of melting, well, that's freezing. Okay, so that's what those arrows mean. Now a gas, on the other hand, okay, a gas over here, the molecules are going to be super far apart from each other. Okay, and they're going to be going a lot faster. Okay, so we've got a lot of energy in gases. Okay, so they're moving with lots of energy. There's real spread apart, and they're not very, interacting or colliding with each other that much. So that is, a gas. So let's go back actually and take a look. Liquids are, moving around each other, right? So they're moving around each other, right? But gases are super spread out. Super spread out, right? And they are fast. All right, so to get from a liquid to a gas, remember we call that boiling or evaporation. All right, so we crank on the heat, to boil water, goes from a liquid to a gas state, that's evaporation. Now to go the opposite way, condensation. Condensation. Okay, so now we kind of have an idea about those molecules in the different states of matter and, kind of how they're interacting with each other and their molecular speed. Okay, so we saw today in the lab that we have what's called this conservation of matter, right? So the law of conservation of matter states that matter can be neither created nor destroyed. Remember, we saw in the lab that the mass of everything that we started with was exactly the mass that we ended with, even though we had different molecules in the end, right? So for example, we started with vinegar and baking soda, right? Certain mass of both, and we put it, we dumped the vinegar into the baking soda. The baking soda into the vinegar. All right, it reacted and made bubbles. The balloon started to inflate a little bit, right? So we actually had different substances, but when you put it on the scale, did it change mass? Absolutely not. Okay, so whatever mass or matter we start with is exactly equal to the mass or matter we end with. So the law of conservation of matter says that matter cannot be created or destroyed. So whatever you start with, whatever mass you start with, whatever atoms you start with, okay, are the same ones you end with. They may be rearranged differently into new compounds. Okay, for example, with the vinegar and the baking soda, right, we had carbon and oxygen in there, okay, and they came together to make carbon dioxide, which is the gas that we felt, that you saw filling up the balloon. Okay, but all of it came from the original atoms that we had in the vinegar and the baking soda. So matter cannot be created nor destroyed during a chemical reaction. All right, the last little bit that I want to talk about is this sideways slide. I'm not sure why it came out sideways on my iPad here, but that's okay. Is this concept of water. Water is super special. Water is awesome. Okay, it's life couldn't survive without water. Water rocks. All right. Your 75% of you is made of water. You need water. You die if you don't have water within 3 days. Water is life. In fact, scientists are trying to figure out if there was water on Mars, because if there was water on Mars, then that might be a prospect of life. We're trying. Water is super, super, super important. And one of the reasons why it's so cool is this idea between different phases of water. So typically, when substances freeze, right, we saw that the molecules come closer together. They condense. They come closer together and they slow down. All right. Water is special. Okay, so here is a picture of water molecules as a liquid. They're kind of close together, right? They're interacting closer together. As soon as we take out the energy, look what happens. Over here, they actually spread apart and crystallize into this cool pattern, like hexagonal pattern. And so none of the other substances really do this. Okay, so that's what this little thing says, weird. And most substances are not like this, where they actually, when they solidify, they get farther apart from each other and do this nice crystal form. Most, just bring the atoms closer together. So this is super important because it makes water have the ability to float, right, as ice. So ice floats, and you may, think, well, okay, who cares? Ice floats. It doesn't matter if the ice is on the top of my drink or the bottom of my drink, right? It makes it cold. It does matter in marine and water environments, right? So like lakes, streams, and rivers that freeze. If the ice got so dense that it sank through the water, okay, then you would kill all the life in the lakes, streams, and rivers, because all the ice would go to the bottom. We wouldn't have, it would kill the plants down there. It wouldn't allow them to thrive. And if you have no plants, then you have no small animals. And if you have no small animals, you have no big animals. You guys know that from biology. So it's super important that ice floats, because if ice floats, then the ice will be up on top here, and the plants, okay, right, can still grow underneath, and we could still have our fish and other animals and whatnot living underneath, okay, the ice, and it'll still, allow life to go on. Okay, so really cool thing about water is ice floats. So the next time you're having a drink with some ice and the ice cubes are floating in the water, all right, you just be like, yeah, that's awesome. Okay, because without it, then we wouldn't have any life. Without that feature of water, we wouldn't have any life in the aquatic environments. All right, so that is it for our matter notes. Stay tuned, and next class we'll be talking and digging more into matter.